Okay, so we're continuing our discussion of the Poincare classification diagram. Now that we've kind of seen how it works, let's go ahead and try a few examples of how we might use it. And so suppose I have x prime is equal to 2 minus 1, 3 minus 2 times x. And notice that the origin is the classification, is the equilibrium solution that I'm trying to classify here. And so I need, in order to use the diagram, I need the trace, the determinant, and then I need to know if I'm inside or outside of the parabola. So I need the discriminant as well. So the trace of a in this case is 2 minus 2, which is 0. Determinant of a is minus 4 plus 3, which is minus 1, so that's negative. And the discriminant is going to be 0 squared minus 4 times minus 1, which is 4. So where are we in our picture? If the trace of 0, the trace is 0 and the determinant's minus 1, we're here. Do you remember what that was? Saddle. Good. Okay. So we know to expect a saddle in our classification. Let's try some more. How about x prime equals 3 minus 2, 4 minus 1 times x. So similarly, we want the trace, we want the determinant, and we want the discriminant. Okay, the trace is going to be 3 minus 1, which is 2. Determinant is minus 3 plus 8, which is 5, so that's positive. Both of these are positive so far. So where are we in the trace determinant plane so far? So far, let me try a different color here. We're in the first quadrant. So the big question then is whether or not we're inside or outside the parabola. And so if we compute the discriminant, we get 2 squared minus 4 times 5. That's going to be a negative number. And so therefore, we are inside, and so therefore we have a spiral, or we will have a spiral source. Okay, so spiral sources are inside the parabola. Very good. And so you can do things like that for any matrix. Oh, my squeaky chair is going for it again here. So let's try to do one more example here. And this is kind of an interesting example of using the Poincare classification diagram because of my matrix A now is going to be dependent on a parameter. And the parameter is A. And so the question is how does the classification, let me see if I can write this better. How does the classification change with changing A? Right? So, again, boy, this loud chair is loud. Trace of A, I have to speak up, is A minus 1. Determinant is going to be, let's see, minus A minus 3A is minus 4A. And then the discriminant will be A minus 1 squared minus 4 times the determinant. Let's see if we can simplify that a little bit. A squared minus 2A plus 1, you can hear my clock in the background, minus 16A, right? Oops, my discriminant was negative, so this should be plus, right? That's plus. Okay, so now I'm going to rewrite that. A squared, I'm just simplifying this a little bit because as it turns out, I'm going to want to know where this parabola is equal to 0, right? Because that's where the discriminant is equal to 0. So it might be handy to have this written in a factored form or complete the square. So that's going to be, let's see, half of 14 is 7, squared is 49. So if I say this is a squared plus 14a plus 49 plus, and then 1 minus 49, right? Then this is going to be a plus 7 squared. What's that? Minus 48. Good. And so if I set that equal to 0, a is equal to minus 7 plus or minus the square root of 48. And just for future reference, right, both of these values are negative, right? Both are negative. And so instead of writing these down all the time, let's call these P1 and P2. So I think P2 or P1 will make the one that's closer to 0, and then P2 the one that's farther away from 0. Okay. So anyway, let's summarize here. I've got a trace that's here, that's a minus 1. A determinant is minus 4a, and then the discriminant is equal to this expression, which is a parabola. And what does that parabola look like? Right, it opens up. And so between the points P1 and P2, my discriminant is going to be negative. Okay. All right. So now there is a way that I can actually graphically determine what's going on here. And so I might just spend a minute doing that. Because sometimes it's really hard to do it this way. Although, yeah, it's sometimes hard to do. So this is my trace determinant plane. And so what's going to happen, I don't know if I'm going to be able to get this very well. Maybe I should have drawn my line first. Let me draw my line first. Because if the trace is a minus 1 and the determinant is minus 4a, then you can see from this, right, that the a is equal to the trace of a plus 1. And so you could write the determinant of a is minus 4 times the trace of a plus 1. Or you could think of it as y equals minus 4 times x plus 1. That's probably easier to think about it that way. Good. So this actually looks like a line, right? It goes through minus 4. And then what's going to happen is my parabola is going to intersect it. This is why I had to draw that line first. Okay. I think we're ready now. So where am I at this point right here? That's where the trace is equal to 0. So this is where the trace is 0. The trace is a minus 1. So this point is where a is equal to 1. Right? Now this point right here is where the determinant is equal to 0. Where is the determinant equal to 0? That's at a equals 0. So this is at a equals 0. And so you can already see we're in this region if a is bigger than 1. Whoops. We're in this region if a is between 0 and 1. And so this point is where a is equal to p sub 1. And this point is where a is equal to p sub 2. So what happens if a is between p sub 1 and p sub 2? We're going to have a spiral sink. This is going to be a sink. This is going to be a sink. This region is going to be a spiral sink. And then we come back to a sink again when we get out here. Okay. And so we can identify all the different places where the category of the origin changes. There is an algebraic way of doing that as well, but it's not as much fun. By the way, if a is just less than 0, we see that we get a saddle, right? We don't have to distinguish between these cases down here. Okay, at a equals 0, we do get a line of fixed points. And then at these 2 points, if you look at the Poincare classification diagram, this is called a degenerate sink. Good. And so using this diagram now, I've got all my different A values lined up. So if A is bigger than 0, or sorry, did I say less than 0? I meant greater than 0. Did anybody catch that? That's why I need you guys in class so you can catch my errors. Okay, so if A is positive, we have a saddle. If A is negative, that means we're in this region here. Okay, and then like we said before, this is where A is moving between P1 and P2 as A gets negative and more negative. All right, and so we move from a sink to a degenerate sink to a spiral sink to a degenerate sink to a sink. All right, that was fun. Okay. I think I will let you read through the rest. There's a couple more homework problems there that are just review. And we're not doing anything too different in the homework. This is probably the most difficult Poincare classification problem we'll be doing. So if you understood that one, I think you'll be in good shape. It's all written out in detail in the notes, though, so I would encourage you to read those over. I tried to include lots of graphs. Good. I will see you later.